Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Today we will learn about the use of condition structure, the use of loop structure. Let's go to the strategy editing page. We will learn the loop of for. The use of the for statement has been used in our previous video courses. Let's write the form of the basic structure of a for loop. First, we will use pseudocode to write the basic form of the for loop. The for loop, like the condition structure we talked before in the previous lesson, can also receive a return value. For example, if there is a return value, we use the equal operator to assign it. And then we write the for loop. The loop body is able to return a return value at the end, and then assign a value to the return value. In the for loop, the keyword for is immediately followed by a variable that counts to be assigned an initial count. Here we use the keyword to so that it gets the final count, and then we use the keyword by. Write the step length. In this way, we finish writing the first sentence of the for loop. To and by here. To. The next line, we write the loop body. We can write some statements such as assignment statements, function calls, etc. The last statement is the return value of the for loop. For example, the last statement is an assignment of a variable, and then the variable is returned as the return value of the for loop. Let's write a specific example for illustration. A for loop can return not only a single value but also multiple values in the form of tuple, such as returning values in the form of tuple, such as A, B, C. It is also possible to return on the for loop. The for loop is mainly used for loop count, for loop number control, and the for loop is a finite number of loops. The count at the beginning is called the initial count. For example, here we declare a variable red. Create a for loop here. And we name the initial loop count as I. We assign the initial loop count to 0. And the termination loop count to 10. From 0 to 10. Thus, we finish a loop body here. Next, we write the statement for the execution of the for loop. We write runtime log. Print the specific value, and then we write I. We write I on the next line, returning I to the variable red. as the return value of the variable. We also use the runtime log function in this last global scope. Print out the variable net, red. And then throw an error to stop the strategy when it backtests. We use the runtime error function. Stop. That is, we just let the for loop run, print it, and let the strategy stop. For loop is actually a loop we write a loop count variable after for. This count variable is declared as I. Its initial value is 0, and when it runs, each time I increments. If no step length is written, it will be incremented according to the default value of 1. That is, I of the first loop is 0. I of the second loop is 1. It increments to 10. After that, the loop stops. The loop body of this code is executed for each period. That is, print the specific value of I. Here we click Backtest. Wait for a moment. We can see in the log message column, the strategy runs for 10 times. The first time it printed 0 here. Then it's 1, 2, 3, and so on until 10. And finally, a value is returned, and the strategy stops. In the code page, we wrote the for loop to run. We can also write break, continue, and other keywords besides statements in the for loop. The break keyword used in the for loop. The loop stops when the break statement is executed. The continue. The continue keyword is used in the for loop. When the continue statement is executed, the loop will ignore the code after continue and execute the next round of the loop directly. The for statement returns to the return value from the last execution of the loop, and it returns null if no code is executed. Then we use a simple example to demonstrate. Use the if statement we have learned. Write it here. If I equals to 3, we let it break. That is, let the loop jump out when I equals to 3. Here we click Backtest. We can see that when I is 3 in the log log message column, it jumps out and then perform the print red with 3. Let's go back to the code page. We can also use continue here. Let the loop skip the following loop. Here we click backtest. And we can see that there are I equals to 0, 1, 2, 4, but I equals to 3 wasn't executed. That is to say, it skipped over. Let's go back to the code page. We executed continue when I equals to 3. That is, it skips the following code directly and re-executes the loop when I equals to 3. Of course, we can also add the keyword by to the for loop. We can add it here by 2. And each time the variable I will be incremented by 2. Here we click backtest to see it. We can see that I is 0 here at the beginning. Then it becomes 2 by adding 2, then 4, 6, 8, 10, 12. This is the step length change of the loop count. The for loop in the Pine language on FMZ only supports forward loops currently, not reverse loops for now. However, the reverse loop is supported on TradingView. For example, we can write the initial variable as 10 and the termination variable as 0. It will start from 10 and decrement the loop to 0. Next, let's move to for in statement. It is mainly used as a loop for array elements. We'll explain arrays in the video tutorial later. Here we can understand it briefly. For in statement has 2 forms. Let's start with the first one, for in loop without array index. Of course, the for in loops, like the for loops, can also use break and continue, as well as return values. Let's write an example. We declare a variable test array. Then we use the function array from to construct an array. There is 10 elements in the array. Then we use the we can write 10, 20, 30, 40, 50, 60, 70. there is 10 elements in the array. Then we use the for-in statement to iterate through the array loop. We write for element in test array. And we write runtime log. Print ELE. Then finally we let the loop stop after executing one loop. So we use runtime error function and let it throw an error. Then we click backtest. We can see that the loop prints each element of the array in the loop. First is 10, and then 20, 30, 40 to 100. So that's for-in loop without array index. The second form is for-in loop with array index. It's similar to the example we have just given. We can modify it directly. When we declare a temporary variable for a loop element, we write it in a form with an index. We enclose the first variable in brackets. The first variable I is the index value of the array. That is, the index of 10 is 0. The index of 20 is 1, and so on. Then I becomes the index value of the array. ELE is the specific element value of the array. Then we modify the runtime log function. We print out the index I as well. Then we click backtest. And we can see that the program not only gets the value of the element of the array, but also its corresponding index. Here the index corresponding to element 10 is 0. The index corresponding to element 20 is 1, and so on. The last element, 100, is the index corresponding to it is 9 here. For the application of for loops, we can use the built-in functions provided in the Pine language. To complete some of the loop logical calculations, either written by using the loop structure directly or processed using the built-in functions. Let's take an example. If we want to calculate the mean value, we declare a global variable, length, let it equal to 5. Then we declare an array, A, use var. We use the function array_new to create an empty array. We write length in it. The function array_new means we create a new array. Here we assign it to variable a, and the length of the new array is 5. If no field value is specified, the default field value here is an a. Then we use the function array_push. Write a close here. That is, put the closing price of the current k-line bar in the last position of the array. Then we use array size to determine the length of array A. If the length more than or equal to length, then we use the function array_move. Oh, sorry, it's the function array_remove. We use the function array_remove to remove the array element with index 0. Then we declare a variable sum equals to 0. It's 0. Then we write a loop with for in. Iterate through the array A. Each array element in A is the variable ELE, and we accumulate them all to sum. It is equivalent to adding all the elements of the array together. Then we declare an average variable avg and divide sum by length equals to sum divided by length. We use the plot function to print out avg. Name it as avg here. And let it draw on the main chart. That is to say, we implement an average calculation with a period of 5 by using the for loop. Then we click backtest. We can see that an average line with a period of 5 is drawn on the chart. Let's go back to the code page. In the Python language, we prefer to use functions directly for computation. For loops are mainly used for tasks that cannot be done with built-in functions. For example, we can use the built-in function TASMA directly to calculate the moving average indicator. We pass in close and length. Name it as TASMA. Let it draw on the main chart. We make a guess here. Will the two lines drawn out will be the same? We click backtest to see it. We can see that these two lines on the chart are exactly overlapping, and the average values printed on the chart are exactly the same. That is, the indicator calculated for each k line is exactly the same. In other words, the algorithm we constructed with the for loop is exactly the same as the average line calculated directly with the built-in function indicator. In addition, handler functions on arrays can also perform calculations in place of some loops. We still use the example above to illustrate. When summing, we can use the function array sum and modify it in the loop. We can delete sum equals to 0 and the loop. As well as the AVG. Then we modify the plot function. Red array here. Pass the array in array A directly. This function then returns an array. The sum of all the elements of an array is added up. And then we divide this sum by length. This is how the averages are calculated. We click Backtest. And we can see that the chart drawn out is the same as the one we just processed with the for loop, and the indicators on each k-line bar are the same. These two averages also overlaps exactly. So why design loops when we can do all these with built-in functions? The use of loops is mainly based on the application of the 3 points. First, for some operations on arrays calculations. Second, to review the history, for example, to find out how many past high points are higher than the current bar high point. Since the high point of the current bar is only known at the bar where the script is running, a loop is needed to return and analyze the past bar in time. Third, the use of the built-in functions of the Python language cannot complete the calculation of past bars. In addition, there is the while loop, which is similar to the for loop in that the for loop is a finite number of loops. If the loop condition is always true, then the while loop is an infinite loop. While loops can also have return values. For example, we use the pseudocode to write return value. Return value equals to while judgment condition. We start a new line. We write the body of the while loop. We can write various statements. Such as function calls, expressions, assignment operations, etc. The while loop, like the for loop, has a last statement. That is used as the return value of the while loop. While loops can also include keywords like break and continue. The loop is executed when the loop condition is true, and it stops when the condition is false. We will still use the example of calculating averages for demonstration. We declare a variable length. Let it equal to 10. That is, we initialize it to 10 here. Then we write SMA. Write a custom function data and a parameter length in it. This custom function is used to calculate the mean value. We initialize a local variable I and let it equal to 0. Then we write sum equals to 0 here. Here we write the while loop. It executes the loop when I less than 10. We accumulate sum inside the loop. We use the historical operator to quote the previous values and add them up. We continue to write let I self-added. And divided the sum by length. As the return value for while, we divided the sum by length as the divided return value for while. Let's take a look at this execution process. If we call this custom function with the plot function, we pass in close and length. It will pass close into data and length into the form parameter. And this time it will start declaring a variable I, initialize it to 0, and then declaring the variable sum, initialize it to 0, and then the loop is executed. And when I is less than 10, the loop body is executed. Accumulate the current keyline bar into sum, and let I add 1. While statement returns at the final return value of the SMA function. The second cycle lets I add 1, and I becomes 2. At this point, the closing price is accumulated until 10. Closing price are accumulated and divided by 10, so that the average with a period of 10 is calculated. Here we use the plot function to draw SMA. We pass in close and length, name it as SMA here. And let it draw on the main chart. To verify whether our algorithm can achieve the effect of averaging, we use the built-in indicator function of TradingView to find the average line for comparison. We draw the TASMA just the same as above. Copy and change it. TASMA. Name it as TASMA. We click Backtest. We can see that the average value calculated in both ways is the same, and the indicator value on each K-line bar is exactly the same. As we can see that the while loop is also very simple to use, and it is also possible to design some calculation logic that cannot be replaced by the built-in functions, such as calculating factorial. First, we declare a variable counter equals to 5. Then we declare a variable fact equals to 1. We write a return value to let the while loop execute the loop body fact. When counter more than 0. Here we use modify operator and modify the global variable fact. Let factor multiply by the variable counter. Then modify the variable counter so that it self-subtracts by 1. And finally, let factor return as the return value. This loop structure is much simpler. The initial value of the variable counter is 5. If it's greater than 0, it is executed. And when it is reduced to less than 0, it is not executed, and the loop is finished. For our observation, we use the runtime log function to print the counter and fact. Here. And finally, we use the runtime error function to make it stop after running for one time. Here we click Backtest. We can see that in the log message column, the counter is 5 and the factor is 5 at the beginning. Then it becomes 4, 3, 2, 1, and 20, 60, 120, respectively. Here is calculating the factorial of 5. Let's go back to the code page. We can also print it out by using the runtime log function to output the return value red. We write it here. Then we click backtest. And we can see that red is 120 here. So that's all for today's lesson. If you think our video tutorials are useful, don't forget to like, follow, and repost. Your support is our greatest motivation. Thank you all and see you next video.